Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Faza Konita Aulia from State Polytechnic of Padang, Information Technology Department, Software Engineering Technology. Today I want to present my review, a journal review about artificial intelligence, titled A Study on Signature Verification Using Backpropagation Algorithm. This journal is from International Journal of Engineering Research and Technology. So here we are the case we talked about. Signature verification is a very challenging area of study. It is not easy to decipher whether a signature is genuine or forged. Various methods have been developed to measure the genuinity of a signature. This paper talks about one such method, the backpropagation algorithm, which has the highest accuracy. The sole reason of picking up this method is the ease of use and understanding. Also, ways to implement it in an easier way have been talked about. In a later part, the probable areas of improvement values have been suggested. This may be improved and the efficiency can be increased in case the study is extended further. Even today, most of the works, especially in financial and real estate sectors, offline handwritten signatures are preferred. However, perfect and difficult the signatures be, they have a threat of getting forged by anyone. Forgery is defined as imitating objects with an intent to deceive. We classify forgery under two categories. The first is simple forgery, refers to the forger not having access to the original signature and thus forging it in his own style. Skilled forgery is done by artist who has an access to the original signature and is able to produce a deceptive replica of the signature. The second is manual signature, is very basic method for a person to recognize the signer of the document. It is widely used to recognize a person delivering out daily procedures. An example, bank operations, document analysis, electronic funds transfer, and access control. So here the method used for the signature verification. This is the general methods which follows these steps. The first is creating the database. Foremost, for the experiment, a database consisting of all the considered genuine signatures has been created. For the same, the sample space was collected from some chosen individuals whose signatures were to be taken for the experiment and were worked upon. So the first step that we have to do is creating the database contained the signature from some chosen individuals. So we saved it in the database. And the next step is verifying the input signature. To verify, the method used is the backpropagation algorithm, artificial neural networks. So here the steps are explained. The first is preprocessing. Pre-processing algorithms are the data conditioning algorithms for feature extraction process. Pre-processing should include some noise filtering, smoothing, and normalization to correct the image from different errors. Main steps in pre-processing are: the first is conversion of color image to grayscale. Generally, signatures are signed with colored ink, and in order to perform the steps in pre-processing, we need to convert the signature image into the grayscale image. The purpose is to make signature stand out and ready for feature extraction. It improves the quality of the image. It is used to reduce the variations and produce a more consistent set of data. The second is noise reduction. Median filter is widely used for smoothing and restoring images corrupted by noise because of the fact that it reduces impulsive or salt and paper type noise and has attractive properties for suppressing impulsive noise while preserving edges. Salt and pepper is aided because there may be small disturbances which may not be detected while removing noise. To avoid this and remove noise from the image, salt and pepper is added, and then the small disturbances are removed along with the added noise. Number 3, background elimination and border clearing. Thresholding is the easiest and sophisticatedly applicable method for background elimination and border clearing. Number 4 is normalization. Sinus dimensions may vary due to irregularities in image scanning and capturing process. Furthermore, height and weight. Size of the signature may vary from signature to signature. It is thus normalized. During normalization, the ratio of width to height is kept intact. The next step is the feature extraction. Feature extraction is a special form of dimensionality reduction. More than 40 different feature types have been used for signature verification. Features extracted should be easily computed, reduced, rotationally invariant, and insensitive to various distortions and variations in the image. The features that are extracted in this phase are used to create a feature factor. The following step is verification. A feature factor, including all the feature points, is created. Extracted feature points from all the signatures are normalized to the range of 0 to 1. Taking the test signature and making it go through exactly the same steps as pre-processing, feature extraction, and etc. It is put into the trained neural network and the result is calculated using backpropagation algorithm. The next, artificial neural network. Artificial neural networks are generally presented as systems of interconnected neurons which can compute values from inputs. Artificial neural network types vary from those with only one or two layers of single-direction logic to complicated multi-input many-directional feedback loops and layers. And the last, and the key of all above is backpropagation algorithm. The backpropagation algorithm has its artificial neurons organized in layers and send their signals forward, and then the errors are propagated backwards. The network receives inputs by neurons in the input layer, and the output of the network is given by the neurons on an output layer. The backpropagation algorithm uses supervised learning, which means that we provide the algorithm with examples of the input and output. We want the network to compute, and then the difference between actual and expected result is calculated. In other words, we wish to infer the mapping implied by the data. So the conclusion and the result is Since there is no method which has 100% accuracy, the research is still going on in this area to achieve maximum accuracy and to improve the backpropagation algorithm. Some of methods may include the refinement of the gradient descent method. So that's all for me. I hope it will be useful for all of us. Thanks for your attention. And if I had many mistakes, I beg all of your pardon. Wassalamualaikum warahmatullahi wabarakatuh.